So initially, at time 0, there were 100 members in the population, and that its rate of growth is given by this equation. We know a rate of change is a derivative, so that's my p prime, that's my derivative. I want the actual population after 10 months. So we have how the population is changing, but we have to find the actual population. So we have p prime. If I want the population, what do we need to do with this? Okay, from where to where?
0 to 10.
We want 10 months. So antiderivative from 0 to 10 of my function. All right. Antiderivative of 10. 10t is our derivative. Antiderivative of t.
1.
Antiderivative of 0.6 t squared. 0.06 t squared would be 0.02 t to the third. Remember, we don't have to put the plus c because why?
It'll just cancel out.
It's going to cancel out because we are going to evaluate this from 0 to 10. Alright, so what we have to do is plug a 10 in, plug a 0 in, and subtract those things. So if we put in a 10, 10 times 10 is 100. 1/2 times t squared. 10 squared is 100 times a half is 50. T cubed would be 1,000 times 0.02. So it's like 1,000 times 2 over 100. So we get 20. When we put in a 0, all those things are 0. So we get 1/7. That is not my final answer, though. What do we need to do?
1/9.
We've got, this is how much our population changed in 10 months. So it's saying in 10 months we added 170. But it told us that we started with 100. So our total population, we started with 100, we added 170, so we should now be up to 270. Under column. I want to evaluate this, the limit, as n approaches infinity, the sum from 1 to n, 2i over n squared on the interval 0 to 1. We know that the limit as n approaches infinity of the sum from 1 to n. That's just another way of saying an interval, right? Since we're on the interval 0 to 1, this is saying the interval from 0 to 1. What is our change in x going to be here? ending minus the beginning over n. So change in x is 1 over n. X sub I is your change in x times I, or just I over n. So if we think about what we have here, we have a 2, I over n squared, I could separate that into an I over n and a 1 over n. Do you guys agree to that point? You see what I did? Now here's how this helps us. The limit and the sum part turn into the interval. Then I have a 2. I over n is what? That's my x sub I, so I would just replace that with an x. 1 over n is the change in x, which just becomes dx on the end. So this is just another way of saying the integral from 0 to 1 of 2x dx. We've gone where we started with the integral and we had to turn it into the limit. So I want to go the other way. If I start with the limit, can you turn it back into the integral? Because now we know the shortcut for evaluating this integral. What's the antiderivative of 2x? X squared from 0 to 1. So that's 1 squared minus 0 squared, and we get 1. So far, so good. Let's look at this problem. All right. Anytime I've given you something with an absolute value in it, whether we were doing limits or derivatives, did we keep the absolute value? No, we had to rewrite it without. And so we know that an absolute value graph is kind of just a V. And so what we really had to do is find out where that point was and separate it. So that's what we're going to do here. When I say the absolute value of x, okay, we know that you just get what you put in as long as you put in a positive number. What happens if you put in a negative number? It becomes positive, so you get the opposite of what you put in. All right, so what we can actually do, there's a property called the integral union property, which says we can break apart this integral. Since 0 is where this absolute value graph changes direction, we can break apart our integral. We can go from -1 to 0, and then we can go from 0 to 3 and add those two together. All right, if you are between -1 and 0, then you're putting in a negative, so the absolute value turns it positive, right? So the absolute value of x is like a negative x. So 2 times negative x is a negative 2x dx. If you go from 0 to 3, you're putting in a positive, so the absolute value doesn't change it, so that's just a 2x dx. Does everybody see how we got there? What's the antiderivative of negative 2x? Negative x squared from negative 1 to 0. Please make sure you're using proper notation and writing that vertical line. Antiderivative of x squared, or of 2x, is x squared from 0 to 3. Alright, so over here, if I put in a 0, we get a 0, minus, if you put in negative 1. Negative 1 squared is 1, opposite of that would be a negative 1. Okay, over here, 3 squared is 9, minus 0 squared is 0. So we get 1 plus 9, or 10. You okay with that one? Let's do another absolute value one. I asked for the interval from negative 4 to positive 2 of the absolute value of x plus 3 dx. Where would we have to break this one up? It's at whatever makes the inside of the absolute value 0. Negative 3. So we have to figure out when x plus 3 is 0, so that's negative 3. So we're going to go from negative 4 to negative 3, and then we'll go from negative 3 to positive 2. All right, if you're between negative 4 and negative 3, so if we put a negative 4 in, you're going to get a negative answer, and the absolute value does the opposite of that. So it would be the opposite of x plus 3. If you're between negative 3 and 2, when you plug it in, you get a positive, so the absolute value doesn't change anything. So we have a negative. What's the antiderivative of x? And the antiderivative of 3? Okay, so here it's 1/2 x squared plus 3x. You're welcome to distribute that negative, or you can pull it out in front. So if we put in a negative 3, negative 3 squared is 9 times 1/2, plus 3 times negative 3, so minus 9. Minus, if I put in a negative 4, we get 16 over 2, so 8. 3 times negative 4 is negative 12. Over here, if I put in a 2, 4 times 1/2 is 2, plus 6, minus 1/2 is minus 9. so then we just have to simplify from here. You guys are double checking my math, right? So I've really shown you two other types of problems today. Do we need more examples of anything I've done?
Like 17
When it was written as the summation?
Yeah.
Okay. So let's say, I don't know how much I trust myself to do this, it works out nicely. I gave you okay, so if I asked you to evaluate this with an interval. So think about when you had an interval and you had turned into this. We had to start out with our change in x and our x sub I, right? So we have to do that here. Change in x would be 2 minus 0 over n, or 2 over n. X sub I is your starting point plus 2 over n times I. Okay. So we need to figure out how we can maybe rewrite this to help us understand what's going on. Eight over n cubed I squared. You always have to separate off a change in x. So my change in x was 2 over n. I've got to pull that off. If I take that away, then you're left with 4 over n squared I squared. Right. Because that's a square, if I move this square on the outside, then that's like a 2 over n times I, all being squared. Do you see that part? So when we go to write this as an interval, the limit part becomes my interval. And my interval was 0 to 2. This was my x sub I. So that just changes into an x. So it would be an x, and that had a square on it. My change in x becomes dx. So we had the integral from 0 to 2 of x squared dx. So then we can evaluate. Antiderivative of x squared is 1/3 x cubed from 0 to 2. So you can pull the 1/3 out if you wanted. So 2 cubed is 8, minus 0 cubed is 0. And we'll get 8/3. Is that one better? Other questions? So let's just spend the rest of the class working on that handout. It's due tomorrow. We are